Greetings, students. This is the third set and the final set of geologic time notes, and it's about fossils. Evidence of life on Earth is often preserved in rocks called fossils. A fossil is the remains, impression, or any evidence of a living organism preserved in sedimentary rock. Fossils are only found in sedimentary rock. But why? Because the temperature and pressure required to create metamorphic or igneous rock would destroy any fossil present. So in this image, you can see the potential for the creation of sedimentary rock, igneous rock, and metamorphic rock. Igneous rock is formed from molten rock. That would be the red inside the volcano here. And when it hardens, it becomes an igneous rock. If you have rocks that are near the molten rock, but they're not melted themselves, they might become a metamorphic rock. Sedimentary rocks form at the bottom of a body of water in a much cooler process that is good for preserving remains. And so sediment piles upon sediment piles upon sediment underneath the water, and you can have things stuck in there. Fossils provide evidence that life on Earth has changed over geologic time. The organisms that were around 250 million years ago are far different than the organisms that were around 4 billion years ago, and far different from the organisms that are around today. There are three types of fossils you need to know: mold fossils, cast fossils, and trace fossils. A mold fossil is empty space. So where the organism was, but the organism's gone and the rock hardened, preserving the space where the organism was. A mold fossil is empty space in the form of a cavity or impression in rock where a plant or animal was buried. Here's an example of a mold fossil. Example: a clam dies and gets covered in sediment at the bottom of an ocean. The sediment is compacted and cemented into sedimentary rock. The clam deteriorates and disappears, leaving behind its shape as an impression in the sedimentary rock. A cast is a fossil that is formed when a new sedimentary rock, volcanic ash, or minerals fill the space left by the mold fossil. A cast is a copy of the organism's shape. So you need to have the mold first, and then maybe the cast is created by volcanic ash or minerals or sedimentary rock. Here's the example. A plant dies and falls into mud. The plant decays, but the mud hardens into a rock. When a nearby volcano erupts, volcanic ash fills the space left by the plant, creating a copy of the plant's shape. Over the course of millions of years, the original mudstone gets eroded, but the volcanic ash does not. So you got your mold on the left and the cast on the right. A mold is the empty space, the cast is what fills it. And this is often used in art. You make a mold to create a sculpture sometimes. And so the mold is the orange here, and the cast is the gray. And so that mold could make the cast over and over and over again. And it's the same way with fossils. You could find just the mold, or sometimes you find the cast. Here the mold is white, and the cast is blue. The third kind is trace fossils. A trace fossil can be two things. It's either a fossilized mark that is formed in soft sediment by the movement of an animal, such as footprints, tail dragging, or some kind of burrow. Or a trace fossil can be the actual hardened remains of a part of an animal, such as hair, teeth, dung, or even the entire organism. So this bug caught in amber on the left side, that would be a trace fossil. In the middle, you have some kind of worm burrows in sediment, and then on the right you have footprints that were hardened into rock. Those are all trace fossils. So fossils are usually made of sedimentary rock, but sometimes they're part of an organism. If part of an organism is preserved, it's the hard parts that are preserved, like bones, teeth, shells, etc., while soft tissues will most likely decay. Another type of fossil to know about is an index fossil. Now, this isn't the same as like cast, mold, or trace, any one of those could be an index fossil. An index fossil has to do with what type of organism it was. Index fossils are special. These fossils are fossils that allow scientists to date the rock that it is found in just because of the fossil that is present. There's certain species that are the hallmark of a certain geologic age. For example, certain types of trilobite fossils were made by organisms that only existed during the Paleozoic era. So if you find these trilobite fossils, you can say this rock formed during the Paleozoic era. So if a paleontologist finds a piece of sedimentary rock with these trilobite fossils embedded, they can say with some certainty that the rock is between 245 and 600 million years old. The trilobite fossil is an index fossil. It could be traced, cast, or mold. The important thing is the particular organism that made the fossil. So the rules to have an index fossil: the organism must be extinct, the fossil must be easily identifiable, the organism and its fossils must have been geographically widespread. It doesn't really help you if it's only in a particular area of the planet. And the organism can only have existed for a relatively short period of geologic history. For example, if you have a crocodile fossil, it's not going to help you to date the rock because crocodiles still exist today. And this chart shows some examples of index fossils and the eras or periods during which they were widespread. And I'll give a few examples here. Ammonite fossils were marine organisms common during the Mesozoic era, and they went extinct during the Kt extinction. That's the extinction that killed the dinosaurs 65 million years ago. And so if you find a rock with ammonite fossils in it, you know that it's at least 65 million years old and maybe as old as 245 million years old, because that's when the organisms were widespread. Narinia fossils, this is a sea snail that lived primarily during the Jurassic period, 206 million to 144 million years ago. And then there's Argopecten gibbus. These are scallop fossils, the shells of a common bivalve mollusk that is still found in the ocean today. But these fossils don't appear in the fossil record until the Quaternary period, beginning 1.8 million years ago. So if you find these fossils, you know that the rock is very recent. So index fossils allow scientists to correlate rock layers around the world as forming during a similar period. And depending on the geologic activity, a layer of a certain period might be further down or closer to the surface. But if it has those fossils, you can say with some certainty that it's a certain age. Sedimentary rocks with Narinia fossils must have formed during that particular window of time, the Jurassic period, no matter where the location. And Virginia fossils. Most Virginia fossils are of marine organisms. This indicates that large areas of the state have been periodically covered in seawater. Paleozoic, Mesozoic, and Cenozoic fossils are found in Virginia. And that is the fossil notes. So this is what it'll look like if you type it up on one slide. You can take up more than one slide if you need to. You can also handwrite it or use my fill in the blank option.